Okay, so on this question, they're asking us to use the Desmos graph limits and continuity. So what you want to do is click on that and it'll open up in a new window for you. It'll look like this. When it opens up in that new window, you'll see this graph they're talking about. And then all these questions pertain to that graph. So their first question is, after making this adjustment to the Desmos graph, the numerical value of the limit at x equals 3 from the left is, so what adjustment are they talking about? Well, they want you to basically move the blue point from 3, 2 to 3, 4. 3, 2 to 3, 4. So that means this blue point right here. See how it's at up over 3 up 2 right now? Over 3 up 2. They're calling A the second coordinate, the y coordinate basically. You can do that two ways. You can just grab it with your mouse or finger or whatever and move it. Oh, wait, from 3, 2 to 3, 4. So over 3 up 2 up to there, I guess. Yeah, up to there. Put it right there. Or you can just grab this A and move that until A is 4. So right now it's at 2. Move it until A is at 4. Move that slider. Either way, that'll do it. That'll move it. And when you do, the point will come up here like this. Then we can answer the question. After making that adjustment, the numerical value for the limit at x equals 3 from the left. So from the left, meaning if you're coming to 3, but you're coming from the left, what is your limit? The limit from the left is, it says right there, I've kind of written over it now, um, y equals 1, because it's coming to a height of 1 from the left. A limit is the height you're approaching, not where you end up. Again, a limit is the height you approach, you head towards, not where you actually end up. Because you might say, well, it's just an open dot there, Mr. It doesn't, it actually jumps up to here. Yeah, I know, but a limit is not where you end up, it's where you're headed to. So from the left, it appears to be headed to a height of 1. And so that's why that answer is 1. Next question. After making the adjustment, the limit from the right. Now, from the right side, this is the right side of that point, and this was the left. From the right side, the limit is headed to a height of 4. Limit from the right is 4, height of 4. And then finally, after making the adjustment, the value of the function itself at 3. So at 3, this is 3 here. Now there's where the dot actually is. It is at a height of 4 also. So that's why that's also 4. It wasn't originally. Originally it was a height of 2, right? But we moved it up. Final question in this here. By using the slider for x0 or dragging the red point, currently located at 5, 2, explore the graph as x decreases from 5 to 2. Which of the following is true? Well, we'll see that what's actually true is the function is continuous from the right. You can see if you were to trace this function, if you go from the left, right there, you get an open dot. So you got to jump up to here to keep going with the graph. So from the left, you have to jump, and it doesn't this open dot there. But from the right, it stops right there with a solid dot. So it's continuous from the right. It's continuous from the right, as it says right here. But it doesn't say it now, but it is continuous from the right. So that's the answer there. Because why? Because it actually comes to a stop, gets all the way to 3. So the question you wonder, how do you continuous from the left to the right? Where you're continuous from the left to the right. If you come all the way to a stop, a solid dot, all the way to that value, all the way to 3, and you never had to pick up your pen. So yeah, we can get all the way to 3 without picking your pen. They might say, yeah, but then there's a jump after that. Yeah, but we've already made it to 3. So it's continuous from the right at 3, not past 3, not at 2.5. I agree, but at 3 from the right, yes, it stops right there. Never had to pick up my pen. But from the left, to get all the way, you get really close to 3, but to get all the way to 3, I got to jump up here. Got to pick up my pen. It's not continuous from the left. only from the right. And it's not continuous overall, because overall has to mean left and right, just like for limits. And so there we go.